Today I'd like to talk to you about inverse trigonometry. Just like adding's inverse is subtracting, multiplying's inverse is dividing, well, all the trig ratios, sine, cosine, and tangent all have an inverse as well. So it is called inverse trigonometry because regular trigonometry up to this point always solved for the sides. You were given a ratio of sides. So inverse trigonometry will solve for the angles. So when you do not know what an angle is, you can use inverse trig on it. So let's just review our trig functions. Sine, opposite over hypotenuse, or y over r. Cosine, adjacent over hypotenuse, or x over r. Tangent, opposite over adjacent, or y over x. And then it's according reciprocal functions, cosecant, secant, and cotangent. Likewise, we need to remember something about inverses here. So I'm going to plot this function, y equals x squared. So we have 0, 0, 1, 1, and its reflective point, 2, 4, and its reflective point, and I get this parabola. So there is my function. We want to see if the inverse is a function. So to do that, remember we have to draw a horizontal line test. And I see that the inverse to x squared is not a function because there are 2 points in common with the horizontal line test. So right down here, I have the graphs of sine, cosine, and tangent. Let's check if their inverse is a function. No, no, no. So none of these inverses are a function. So that is why, in order to use the inverse, we need to limit the domain, which means from what x values to what x values will it remain a function. So that means when we're looking at inverse sine, if I only look at this part of the graph from here to here, I can see that that would be a function. So if I do my horizontal line test through there, I see it does not repeat itself. So where we're going to use that is when we are solving for our angle again. So notice this first one says sine inverse of the ratio y over r. How I know it's sine inverse is because it is raised to the -1 power. Just like I used to write my inverses as f -1 of x. That showed an inverse of the function f. Well, this is the function sine. So sine -1 of the ratio equals my angle theta. And then cosine inverse of the ratio equals theta. And tangent inverse of the ratio equals theta, where theta is always my angle. So our domain for sine inverse is going to be limited between -90 degrees and +90 degrees. That means the inverse sine can be used in quadrant 1 and in quadrant 4. Cosine inverse can be used between 0 and 180 degrees, quadrant 1 and quadrant 2. And tangent inverse is also domain is limited to quadrant 1 and quadrant 4. So as you can see, we can use the inverse function on any of the angles in these quadrants. In Algebra 2, we're going to only look at our angles in quadrant 1, and we can see that the inverse function is okay in those quadrants. You also are going to need to remember your 45, 45, 90 triangle. That across from a 45 is 1, across from a 45 is 1, and across from your 90 is square root 2. And your 30, 60, 90 triangle. Across from your 30 is 1, across from your 60 is square root 3, across from your 90 is 2. So if I am given the ratio of 1 over the square root of 2, when I would do some trig, I would actually simplify that to square root 2 over 2. So this ratio is the simplified version. What you have to remember is if you ever see square root 2 over 2, that it came from this original ratio, 1 over square root 2. And anytime I have square root 2 involved and 1, it comes from a 45, 45, 90 triangle. So we know our angles are going to be 45 degrees. When we have 1 over square root 3 and we had done trig on it, we would have simplified that ratio to square root 3 over 3. So anytime you have this ratio, square root 3 over 3, you have to remember that it was 1 over square root 3 before it was simplified. And when I have 1 and a square root 3 involved, I know it comes from a 30, 60, 90 triangle. So depending on the trig ratio, it is either a 30 degree or a 60 degree. Likewise, if I had 2 over square root 3, that would have been simplified to 2 square root 3 over 3. Anytime I have this simplified ratio, I'm going to have to remember that it came from 2 divided by the square root of 3. And when I have ratios of 2 and square root 3, I must also remember that is in a 30, 60, 90 triangle. So I'm either dealing with the 30 degree or the 60 degree, because inverse trig will always be of the acute angle. So let's try a few. I have sine inverse of square root 2 over 2 equals theta. Well, there I see that simplified version. So that actually means sine inverse of 1 over square root 2. That's where it would have started, equals theta. So since I'm always in the first quadrant, I know that my theta is going to be here, and this is going to be my 90. Sine is opposite, so opposite of theta is 1 over hypotenuse. So that means my hypotenuse is square root of 2. Anytime I have 1 and square root 2, I know it comes from a 45, 45, 90. Right here, we can see my theta is 45. All right, let's try a cosine inverse of 1/2. 1/2 doesn't need to be written in the version before it was simplified. So again, I'm going to draw my triangle, and I have my theta here, my right angle here. Cosine. Cosine is adjacent over hypotenuse. So my adjacent is 1, adjacent to theta. My hypotenuse is 2. When I have ratios of 1 and 2, I know that this missing side, 1 squared plus b squared equals 2 squared. That's 1 plus b squared equals 4. That's b squared equals 3. So b is square root 3. Well, I know across from a square root 3 is a 60 degree. Across from the 1 should be the 30 degrees. So right here, I can see that my theta is 60 degrees. Okay. Tangent inverse of 1. Well, it always has to be a ratio, so this should be 1 over 1. So again, my theta, my right angle. Tangent is opposite over adjacent. So I see my opposite is 1, my adjacent is 1. When I have two congruent legs, 1 squared plus 1 squared equals 2 squared, so c is square root 2. So again, this is a 45, 45, 90. So I see that my theta is 45 degrees. Cosine inverse of 1. So again, it's going to be 1 over 1. So here's my theta, is my right angle. Cosine means adjacent over hypotenuse. So my adjacent is 1. My hypotenuse is 1. So this time my missing side, a squared plus 1 squared equals c squared, which is 1 squared. A squared plus 1 equals 1. Subtract 1. A squared equals 0. So a is 0. Well, that is not actually a triangle. When you have a radius or a hypotenuse of 1 and a side of 1, that means it is a quadrantal angle. So quadrantal angles mean they fall on the quadrant. Well, this adjacent is always my x. This opposite is always my y. So I see I have the point 1, 0, x, y. So 1, 0 falls right here. So that is 0 degrees. So my theta ends up being 0 degrees. Let's try tangent inverse of 0. It always has to be a ratio here. So 0 over 1. So I already see that when I do my triangle, my theta is here. Tangent is opposite over adjacent. So opposite my theta is 0. Adjacent to it is 1. So that means this missing side is 1. So again, since the hypotenuse and a leg are the same length, I am going to know it is a quadrantal. So my x value is 0 and my x value is 1 and my y value is 0. So in this case, I have the point 0, 1. 0, 1 falls right here, and that is 90 degrees. Tangent inverse of undefined equals theta. Well, undefined comes from the simplified fraction of 1 divide 0. So on my triangle, my theta is here. Again, tangent means opposite over adjacent. So my opposite is 1. my adjacent is 0. So my radius is 1. Again, radius and a leg are the same, so this is quadrantal. My x is 0, my y is 1. 0, 1 is right here. So that is at 0 degrees. So my theta is 0 degrees. Sine inverse of 1 is theta. So I need my ratio, 1 over 1. So when I draw my triangle, my theta is down here. Opposite is 1 over hypotenuse is 1. So that means this missing side is 0. Again, a quadrantal. My x is 0, my y is 1. 0, 1 falls right here at 90 degrees. Okay, the next one, cosine inverse of 3 equals 0. Well, this needs to be a ratio, so it is 3 over 1. So here's my theta and my right angle. Cosine is adjacent over hypotenuse. So adjacent is 3, hypotenuse is 1. Can your hypotenuse be smaller than your leg? No, so that means this is not possible. There is no angle here because there actually is no triangle here. This says find theta, which is my missing angle. Well, I'm going to do my trig like I normally would. I start with my angle, which is theta, equals this 7 is opposite of my theta. The 12 is my hypotenuse. Opposite over hypotenuse is tangent. So I have the tangent of theta equals, that's wrong. Opposite over hypotenuse is sine. So, ka, toa. So opposite is 7, hypotenuse is 12. I am looking for theta, which is the angle. So that means to find the angle, I'm going to have to do the inverse. So inverse sine on both sides. That should reduce this out, and I get theta equals sine inverse of 7/12. Well, if I would draw my triangle, which I have right here, 7/12 is not any of the special triangles, not a 45, 45, 90, not a 30, 60, 90. So I have no choice but to punch this in my calculator. Sine inverse, so you're going to go second sine of 7 divide 12. And again, make sure your calculator's in degrees, and you get theta equals 35.7 degrees. Let's see if I find it here again. There we are. Theta equals 35.7 degrees. This time it says cosine theta equals 2/3. So if I put my theta and my angle, right angle, cosine theta equals 2/3. So to solve this, I have to do cosine inverse, cosine inverse. So theta equals cosine inverse of 2/3. Cosine is adjacent over hypotenuse. So my adjacent is 2. My hypotenuse is 3. Again, not a special triangle, so I have to do cosine inverse, so second cosine of 2 divide 3. And I get theta is 48.2 degrees. 4.1, tangent inverse. Tangent opposite 4.1 over adjacent 1. Again, no special triangle, so to solve it, I'm going to have to do tangent inverse. So theta equals tangent inverse of 4.1. So I go to my calculator. Second tangent of 4.1. And I get 76.3 degrees. All right, here's a story problem. A sand pile stands 4 feet high. The diameter of the base is 10 feet. So here's my pile of sand. So here's the base of my pile. It says this diameter that goes all the way across the base here is 10 feet. And this pile stands 4 feet. So right here ends up being my right angle. And here's my triangle. Find the angle of repose. There's my theta. So theta equals opposite. Well, this whole side is 10. This length from here to here is 5. So opposite over adjacent is tangent. So the tangent of theta equals opposite 4 over adjacent 5. Well, again, I'm looking for the angle, so I'm going to have to do inverse trig. So tangent inverse both sides. So this gives me theta equals tangent inverse of 4/5. Again, 4 and 5 are not a special triangle, so again I do tangent inverse, so second tangent of 4 divide 5. And I get 38.7 degrees. Now part B says, how tall would the pile be if it had the same angle of repose but a base diameter of 40 feet? So we have a bigger diameter of 40 feet, but still this same angle of 38.7 degrees. We want to know how high is this pile. This length would be 20. So again, I'm going to start with my angle, 38.7 degrees. This H is my opposite. This 20 is my adjacent. So I have the tangent of 38.7 would equal H over 20. To solve that, I'm going to have to multiply both sides by 20. And I get 20 times the tangent of 38.7 degrees equals H. So when I go to my calculator, I'm going to type that in just like it is. 20 times tangent of 38.7. And I get 16.0 is H. So 16 feet high is how tall the pile of sand would stand. This should be enough information for you to do your homework on inverse trig.